In this video, we are looking at the normal distribution. The normal distribution is a continuous probability distribution. It takes this bell-shaped curve. It's symmetrical, so half of the data is above the mean, half is below the mean, and as we go out to the extremes, we get asymptotes. It gets closer and closer to the axis. From a normal distribution, 68% of data is within one standard deviation of the mean. One standard deviation. So within one standard deviation of the mean, so between these two, that would be 68% of the data. Within two standard deviations, we get 95% of the data. So 95% of data within two standard deviations. And within three standard deviations, we get 99.7% of the data is within three standard deviations. We find this distribution occurring naturally. It is the heights of people can be modeled using this, or test scores, or the weights of babies. They all take this distribution. They all follow this shape, this bell curve. Here we have some questions. The heights of some children, x centimeters, are modeled by x is distributed. So that squiggly line means distributed. The n means normally. And then we've got a mean of 120. So the mean is 120. That's the center of our bell curve. And the variance is 9. So that's standard deviation squared. So if standard deviation squared is 9, that means the standard deviation is 3. So what's the probability that x is bigger? What's the probability that a child's height is bigger than 120? Well, 120 is the mean. So we've got exactly 50% above it, 50% below it. So it's 50%, or 0.5. Find the probability the height is between 117 and 123 centimeters. And that's within one standard deviation. So within one standard deviation, we have 68% of the data. So between 117 and 123, that's going to be 68%. Between 114 and 126, that's within two standard deviations. Within two standard deviations, we've got 95% of the data. And 111 and 129, that's within three standard deviations. So 3, 3, so 9 on each side of the mean. And that's 99.7% of the data. Okay, one for you to try. See if you can give it a go. So the weights of some objects are modeled. X is distributed normally with a mean of 2.3 and the standard deviation is 0.2. So the variance is 0.2 squared. Standard deviation is 0.2. What's the probability an object weighs less than 2.3 kilograms? That's 50%. Less than the mean. Remember, we've got a perfectly symmetrical distribution. The mean is exactly halfway, 50% above it, 50% below it. Find the probability that x is between 2.1 and 2.5. That's within one standard deviation of the mean. So 2.1 and 2.5 within one standard deviation of the mean is 68% of the data. And between 1.9 and 2.7, that's within two standard deviations below the mean and two standard deviations above the mean. it's 95% of the data.